Hello. So I'm live, I guess. Let me just check if my voice is coming or not. Oh, yes, my voice is there. So yeah, let's go. Uh, I will be trying some PNC's questions today, either Gupta. So yes, so I'm right now on question number 8, and this was the first question that actually seemed very quite good for me. So the question says that 10 guests are there in which, so there are a total of 10 guests in which there are 3 ladies and other 7 are men's. Other 7 are men. And after that, they have to be seated in a row. The ladies insist on sitting together. So all 3 ladies will sit together, whereas two of the gentlemen, refuse to take consecutive seats, and two of them will not take consecutive seats. So, in how many ways we can arrange them? So, actually, I guess the complement method will be good because of this men constraint. Otherwise, the question was really easy. Because of this men constraint, let me try a method, complement method. A total number of ways if there was no men constraint here would be, since 3 ladies are to be, and they have to sit together, and they will be sitting in the gap created by 7 men, which means 8 gaps, and we will choose any one gap out of them. So there will be 8C1 into, and then they can be, the men can be arranged in 7 factorial ways. Now, so this is 3 factorial into 8 factorial, basically 3 factorial into 8 factorial. And now I have to complement all the ways in which 2 men were sitting together. So there were a total of 8 objects, and now, since there are 6 men, one men group and one women group. Now we have to arrange 7 of them. Okay, so all of those ways will be, out of the 7 gaps that will be created, we have to choose any 2 gaps, and in those 2 gaps we have to fill either of these. So okay, we will multiply it by 2. Let me see if it is correct, and then we have to arrange 2 people together and 3 factorial ways. So this and I will subtract it from 3 factorial into 8 factorial. So trying to evaluate this, 7 factorial upon 2 factorial into 5 factorial. So this will into 2 into 2 into 6. So this will cancel out, and it will be 7 into 6 into 6 into 2. So 3 factorial into 8 factorial is, let me see if it is 7p7. Okay, okay. Let me check if the final answer matches. So 7 into 6 into 6 into 2, 8 factorial into 6. 6 into 8 factorial will be 120 times 7 times 6 times 8. 876 into 5 factorial is 8 factorial. So 8 6 are 48, and 48 sevens are 48 into 7 into 120. So 48 into 7, 6, 5 carry. 7 fours are 28 plus 5. 28 plus 5 is 28 plus 5 is what? 28 plus 5 is 33. 336. Now 336 into 120, whatever that will be, we have to subtract. Now 336 into 12 is equal to 12 1 carry. So double of this 36, 672, and 336 2 6376 is 13, 1 is carry, 70 10 1 carry, 4032. Out of 4032 ways, so my answer is actually coming less, way more less. The answer of this question is in lakhs. Let me think about this again. Okay, 40320. Still it is 8 lakhs. So still it is 4 lakhs. Let me just complete it. 40302 minus, and I have to subtract some. Well, this is coming more. My answer is coming more, and the given answer is 181,440. 181,440. 181,440. Okay, so to make that the answer, let me just complete it once first. So 40320, and I will have to subtract 36 into 14. 36 into 14, so that is 360, plus 36 into 4 is 72 into 2, that is 144. 5, 4, 10, 504. So 504, 43220 minus 504. It will come 40,000 something. Now, 10 guests are to be seated in a row, of which 3 are ladies. Out of 10 guests, 3 are ladies. 10 guests, 3 are ladies, and rest 7 are men. Ladies are to be seated together. They will sit together, while men 1 and men 2 won't sit together. So, firstly, let's arrange. Firstly, take let's make a subjob 1 to makes it 5 of the men. 5 factorial ways to do that. And after the 5 factorial ways, in 6 gaps, I have to select one gap, and in 6 gaps I will have to select one gap for the women and then arrange them multiplied by 3 factorial. And after that, I will have how many gaps? Initially I had total 5 of men and now one ladies group. So there are six elements, so there will be seven gaps. So out of seven gaps, I have to select one, and then no, I out of seven gaps, I have to select two since they won't sit together, and then arrange them. So yeah, this must be the expression. Let's 5 factorial is 120 into 6 even is 6 into 3 factorial is 6 into 7c2. 7c2 is 7 factorial upon 5 factorial into 2 factorial into 2. So 2 factorial cancels out. 120 into 6 squared into 7 into 6. So that makes it 720 into 36 into 7. So 36 into 36 into 2. Okay. So 36 into 36 is equal to 216 into 6. That is 2160 ka half. That is 2160 ka half is 160 ka half. 2160. Half of that is 1080 plus 216. That is 1296. 12960 into 14. 12960 into 14. 12. I guess I will approach the answer. 1296000 plus half of that minus 12960. So half of 1269600. Firstly, this is 1,29,600. So it will be 50,000 plus half of 29,000. That is 50,000 plus 64,800. And I will have to subtract 12960 from 12960. So let's add them up first. Or yes, let's add them up first. So adding them, last 20, then 8. No, once again. Adding them, we get two zeros at the end. 14, 1 carried, 14, 1 carried, 6 to 8, 1, 9, and 1. Now I have to subtract 12960. 12960. I guess I will get the answer. This time 0, 4. Okay, 0, 4. 13 minus 9 is 4. 3 minus 2 is 1. 9 minus 1 is 8. 181440. Yes. Ah, this question is complete. Now, question number 9. Question number 9 is a dictionary is printed of seven lettered words that can be made with letters of the word cricket. If the words are printed in the alphabetical order, as in the ordinary dictionary, find the position. Seven letter words, CRICK. Okay, find the position of the words. So, dictionary problem, and the word here is CRICKET. So, let's do that. CRICKET. So let's give them their rank. So C is first, E is second, I is third, JK is fourth. This is also second. Now R and T are remaining. Third, fourth, JKLMNOPQRS. JKLMNOPQRS. So R will be 5 and this will be 6. This is 1, sorry. This is what 1. Now I have to mark the list of, okay. So I have to mark the list of how many are behind. So for this is 0. Yes, I have to write 0. And all are lesser: 1, 2, 3, 4, 5. 5, 1, 2. Okay, so I have made a mistake. Now let's do this. So 0 for this, and for 5, 1, 2, 3, 4. 4 numbers are there. For this is number 3. 2 people are there. For this 0 are there. For 4 there is 1, there is 0, there is 0. Now I have to divide it by the I have to divide it by the numbers repeating after this. So this is 2 factorial, 2 factorial, 2 factorial, and then there is 1, 1, 1, 1. And multiplying them by their position: 0 factorial, 5, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 6 factorial. Now this, and this. So 4 by 2 factorial is 2 into 120 is 240, and this is 4 factorial. 4 threes are 12 to 224, and 1 into 2 factorial is 2. 266, 266 numbers are behind, so the word will be 267. There is something wrong. Okay, just 2-minute breaks. Well, let's go. Now I'm here again. What wrong thing we did here? So if it was not 4, if it was factorial, let me just replace it by factorial. So 4 factorial is, so it would be 120 into 4 factorial upon 2 factorial. So 4 threes are 12. 110, 10,000. No, that would be massive wrong. 10 to 6. 2, 66. 600 से भी ज़्यादा हो जाएगा ये तो. Let me do it again. Since so let's start again. Let me do this. So CRISCKET. This is number one, number two, number one, number three, number four, number five, number six. Zero greater numbers here. One, two, three, four, five. Four greater numbers here. 4. 24 into 2. 12. Now 1 into 2 factorial. 2 factorial is 2. So let's go. Next question is, I solved this one. Next question is, in a particular programming language, a valid variable can consist of a sequence of 1 to 6 alphanumeric character. A valid variable name 1 to 6 alphanumeric character. Alphanumeric character. And now, okay, alphanumeric character. Beginning with a letter. Okay. And the total number of valid names beginning with a letter. So I guess this is easy. One, 2, 3, 4, 5, 6. Numbers of letters. So 26, 36 की power 5. Okay. Find the total. So the answer is 26 into 36 की power 6 minus 1 upon 35. What the heck? The number of valid variable names of three characters is equal to 26 into 36 and 36 and so on. The total number of valid variable names of 1 to 6 character. 1 plus 26 into 36 plus 26 into 36 square. What is this? So I don't understand this question. Well, how many minutes do we have left in our stream? So yeah, we have plenty of time. So let's go to the next question 11. In how many numbers of 5 digits can be made at least one repeated digit? How many numbers of 5 digits can be made at least one repeated digit? With at least one repeated digit. 1, 2, 3. So total 5 digit minus, okay, so total 5 digit numbers. We How many numbers of 5 digits? So total 5 digit numbers are, we have 9 options, 9 option. We have 9. We have 10 options, 10 options, 10 options, 10 options, and 9 options. 9 into 10 to the power 4 is the total number, and without repetition is 9 times 10 factorial upon 1 to 10, 9, 8, 7, 6 factorials. So 90 into 10 cube minus 9 factorial upon 6 factorial. Now that will be 90 times 1000 subtracted 987. 90 times 987 is 9 sevens are 63 into 8. So 63 into 4 will be 240 plus 12. 40 plus 12 into 2. 252 into 2. 504. 04. 1000 subtracted by 504 is 496. 496 multiplied by 90. 4960 minus 496 is 4. 16 minus 9 is 7. 8 minus 4 is 4, and this is 4. 4474. 44740. 44740. Answer is wrong. Digits. So when at least one digit was repeated, let's go. So total minus non-repeated. Total four digit numbers are 9 into 10 to the power. Total five digit numbers are 9 into 10 to the power 4. And non-repeated 9 digits, 8 digits, 7 digits, 6 digits. Okay, so I understood my mistake. 9 into 10 to the power 4 minus 9 into 9 into 8 into 7 into 6. That comes out to be 62784. How many natural numbers are there lying in between 20,000 to 60,000? The sum of the sum of digits being even. Okay, so 20,000 and 60,000. We have to find out one, 2, 3, 4, 5 digit numbers in which sum of digits is even, and then we will make restrictions on the first digit. So my argument is in half of them the sum of digits will be odd, and in half of them the sum of digits will be even. I'm not very sure, but yes. So 3, 4, 5, 6, 3, 4, 5. These three are valid here, and then 9, 9, 9, 9, 9. Okay, so minus 1 by half. 3 की power 2, 4, 6, 8, 10, 11 minus 1. 3 की power 11 minus 1. Ah, 9 digits cannot be filled here. All 10 digits can be filled. Let's go. 3, 1, 2, 3, 4, 5. Now for all the combinations. 10, 10, 10, 10, 10. and I will divide it by 2. Yes, that's the answer. So yeah, let's go on to the next question. How many even numbers of 4 digits can be made with 0, 3, 5, 4? 0, 3, 5, 4. I have to make even number of 4 digits. 1, 2, 3, 4. Okay, so that's an easy question. How many even number of 4 digits can be made with digits 0, 3, 5, 4? Find the sum of the numbers. Okay, so I have to make all the numbers, and then I have to find out sum of the numbers. Let's firstly see how many numbers are. So firstly, I can have two numbers here, and then when two of the okay, so let me divide it into cases. If I have chosen 4, or if I have chosen, let's say here is 4, let's say here is 0. Now I have two options here. I have two options here, and I have one options here. And here, when I have three options, two options, one options here. So 3, 6 plus 4. 6 plus 4 is 10. Total of 10 numbers can be made. Okay, so let me say total of 10 numbers can be made. So 10 multiplied by all every time the sum of the numbers will be 3. 9 plus 3, that is 12. So 120, I guess. Oh, okay. Okay. So I have done a very stupid thing here. I have added the digits. So yeah, I have added the digits. We have to add the every possible combination of numbers. So every possible number that was made, I have to add them. So my idea is, if nothing will work, I will write all the 10 numbers, and then I will add them up manually. But since they are even, so there will be four numbers. Let me try this way. Ones, tens, sorry, ones, tens, hundreds, and thousands. So here the sum of the numbers, half time 0 will come here, half time 4 will come here. Sorry, not half time, but for 6 times 4 times 4 will come here, and 6 times 0 will come here. So 4 times 4 is 16. And in here, in the first play, in the units place, when 4 was, so for the units place, all the numbers 5 can, all the numbers are 0, 3, 5, 4. When 4 was there, 0 can come, 3 we can come once, 5 can come once, and 4 can come once. No, not 4 can come. 5 plus 3, 8 can come. So 8 is there when 0 is there. 3 can come, 5 can come, 4 can come. So 12. 12 plus 8 is 20. Now let's move to next. And here, when 4 is there, again 20 and again 20. I think so. 20 0 will add up to nothing. 20 and 20. Let me 20 into 1000 plus 20 into 100. 20,000 plus 20,100, that is 2,000, plus 200. 20,000, 2,216. 22216. Answer is 435 45316. So my units place was correct. In 10th place. Uh, that's a difficult calculation. I need a break. I surely need a break. So yeah, I'm ending this broadcast. I will do next broadcast after 12 minutes or something. Thanks.